Welcome again to another edition of the Southwest Climate Podcast. As always, Dr. Don Miguel.
Hi, Zach.
That's my Spanish version for you.
It's really good.
Don Miguel.
Don Miguel? Can I use that at home?
You can.
Okay.
How you been?
Good. And congratulations to you.
Yeah, you guys.
Papa Zachary. Yeah. We had cover for you last time.
I know.
I guess you had an excuse.
I'm kind of surprised you asked me back. Quite frankly,
we figure you're all rested up now.
Well, I did see that the podcast is trending now on Apple. So nice work to you and Ben for
finally. We put it back in its place today.
Yeah, thank you for covering. Yeah, it's been quite the whirlwind.
You look pretty well rested.
I had 8 hours last night.
Good for you.
First time of anywhere near that in like a month.
Store it up. You can take a nap after this.
Yeah. So, which basically means that this podcast is heavily going to rely on you because I haven't
been
really
paying attention?
left the house in a month. So what the heck happened?
This is prime time to look out the window and see what's going on.
It's been eventful.
It has been. It's been an interesting month. Yeah.
Let's get everybody here caught up on the spatial and temporal nuance of the early winter season, Mike. So let me pose the first question to you, which is the pattern of rainfall. If you look at the pattern for November, it's pretty stark. There's a big contrast between a very wet, record-setting in some places actually. So Arizona, much of Arizona, parts of southern Nevada and Utah, and as well as New Mexico have all experienced way above average rainfall for November. And then if you go up north to the Pacific Northwest, super dry. Maybe let's deconstruct that pattern. How did we get there?
It's a great question.
Is it one that you know the answer
to?
No,
I just wanted to say it's a really good question.
Oh, thank you. I had 30 days to think of that.
Complimenting you on your question asking ability. What has happened here? I'm thinking about the sort of progression from October. I think we were together in October for the podcast. Thinking about October, very dry across Arizona and New Mexico. Especially Arizona.
No rain at all at Tucson in October.
Right. So we had a freezing event in the middle of the month and then again at the end of the month, right around
in October.
Really? Yeah. So it's kind of an interesting way to sort of kick off the fall season. So not overly warm, certainly not wet in October like we had seen in the last couple of years, especially thinking back to last October. And then November, I was stressed out about what November might bring because of thinking back to just a year ago. And if you remember, but back to last November, I believe, I might even be thinking of 2 Novembers ago, was the very, very dry. It was actually 2 Novembers ago. Time is going much quicker. 2017 of coming out of the monsoon season, heading into that very warm, record warm fall. Last year was not particularly wet. Last
year we had, in Tucson that is, we had a pretty good October, but then a very dry November.
Yeah,
so it sort of flipped from this year.
That's right. You ended up having that very wet October of last year, tropical storms into a very dry. If I remember correctly, it was kind of midland as far as the temperatures, not particularly warm, not particularly cold, but a very dry November. And so I think that just thinking over the last couple of years, Novembers have not been that kind to us as far as precipitation. You've got to go all the way back to 2013 to see a significantly wet November situation here in Tucson in particular and across much of the Southwest. 2013, did you ride the L Tour?
Wait, was that the one that was wet?
Yes, it was.
That was 2013.
So that month we had 2.22 inches in Tucson, and it rained. Most of the total precipitation in that year or in that particular month happened over the
phenomenal
the
memory.
Tucson. I know, isn't that crazy? Yeah. Well, actually, I just wrote this in a paper, so it was kind of refreshed in my mind. So this last November, the month started off not particularly eventful, and it wasn't until right about the middle of the month we sort of switched into a wet pattern. Ended up having 2 pretty good big pulses of storm activity that moved through Arizona and New Mexico and gave us much of the precipitation that we have on the ground now, or in the gauges, or in the record books.
Right. So Tucson for the month of November saw 2.5-ish inches of rain, more or less. And then we had an additional storm in the first part of December that's taken the tally up close to 3 inches, and it is a fair amount above the historical average.
Yeah.
Not only in Tucson, but pretty much across the Southwest.
Yeah, even Phoenix has actually reached just slightly above average for the cumulative water year total. So starting on October 1st. To date, they typically would see about 1.5 inches and have about 1.68 inches at the airport. Flagstaff in particular has really, after that record dry monsoon season, now has, from October 1st to present, has over 7 inches of precipitation and is now probably 3 inches above average for this time of year. So quite a turnaround from the dry, warm summer into the fall season.
And we needed it for some of those places. And when you look at Arizona as a whole, November now tallies as the third wettest on record, dating back to 125 years, so late 1800s. That's pretty amazing. So when you and I think this is based on PRISM data, but when you spatially average the percent of average, basically Arizona comes in at 320-ish% of average. So that's pretty remarkable. In inches, that's 2.8 inches. Do you know the number one, the wettest November on record
For
Arizona as a whole?
I don't.
Yeah. Well, I wouldn't expect
you look disappointed.
Normally
I'm a little disappointed in myself, actually. How about, let me just throw out some numbers. 1968?
Nope.
1994?
Nope. What else?
Am I close? 1952?
Should we play hot or cold?
No, let's go on forever.
Okay. No. The wettest year on record, actually, you have to go all the way back to 1905.
Really?
And 1978 was the second.
Okay.
And 2019 is the third. So that's remarkable. And in terms of temperature, usually when you have a wet month, you also have a below average temperature, but that wasn't the case this year, actually.
Bucking the trend. Well,
Yep.
We're using trend to buck the trend.
So Arizona as a whole is about 2 degrees above its historical average, and that's sort of in the warmer side of the distribution, but not. It's the 21st out of 125, so obviously above the median, but not like precipitation, not close to record setting. So
the weather pattern from the last time that Ben and I had talked up until our podcast today has been really quite busy across the western U.S. I think the day that Ben and I recorded, I was driving home and started to hear the news reports of the hailstorms that had happened north of here. And there was accumulating hail in Phoenix. It looked like it had snowed.
And that's the mid-November?
Yeah. So this has been on November 21st, I believe, is when that event came. And these events, we've had that one on the 21st, and we had another event that occurred over the Thanksgiving holiday. And then we've had a couple of other ones, have been these low-pressure systems dropping off. Some of them have actually gotten orphaned and been closed lows and even cut off lows. And they look really similar and have behaved very similar to the storm events we had in late September. So the September events that kind of capped off the monsoon season that really weren't monsoonal. We had that low pressure system that got stuck over Yuma and started funneling in subtropical moisture, monsoon moisture at that point in time, and was sparking off those severe thunderstorms. We've subsequently had flash flood warnings and severe thunderstorms with all of these storm events.
Well, so that was another interesting pattern for me, at least. I mean, we did have in the middle of the night, I can't remember what the date was, but there was in the Tucson area, but I think it was probably even broader.
Mm-hmm.
There was thunderstorm late at night and some lightning.
Lots of lightning, yeah.
And that is a characteristic of, you have to entrain pretty warm, moist
juicy,
air.
moist, yeah. So I think it's been, these storms have been able to tap into some subtropical moisture to the south, have been cold storms, and so they just produce wonderful.
So how does that happen? So you have these jet stream at typical at this time of year. You have these wavy jet streams that can loop from the Pacific Northwest down, and if they loop far enough south, they bring the cold air into our region under a trough, and as you have that circulating pattern, you can actually bring up the moisture from the tropics, more or less?
The placement of the storms, if the low pressure system, if the trough comes in and drops the low slightly offshore, it has a better chance, and the amount of time that it takes to sort of move in, and if it's filling in, if it doesn't have upper level dynamics that sort of sustain the pressure fields, they can entrain that moisture from the south and wrap it up, and then have if they're cool core, which these ones are, then they have steep lapse rates. And so those steep lapse rates with moisture at the surface, steep lapse rates are going to support convection. And so we've had some, very vigorous thunderstorms that have actually moved.
But you need there to
area.
be a mix of the cold systems, the cold core from the north, but also the moisture from
the south,
from the tropics.
Yeah. So we've had.
You don't always. Sorry to interrupt.
No,
you don't always get that.
You don't always get that. So there was a heavy rain event, many inches of rain that occurred the day before Thanksgiving of just a couple weeks ago, and there was this stream of subtropical moisture that was coming in over northern Mexico and clipped the southeast part of the state. And it was just persistent heavy rain, no lightning, purely tropical driven moisture getting wrung out and raining out. So that is kind of one way. And those end up they're very warm and they have very high snow levels. And then we had one of these low pressure systems drop in behind it. And that then interacting with the moisture has the dynamics and the instability associated with it to actually produce thunderstorms. And so then you can have the convection, you can have the wind that can come out of that.
It's a combination of patterns or factors.
It's really sort of bringing the cold air and the warm air together to produce those dynamics, and then having the moisture available with it. So we often have these storm systems drop in and move through the region, but they're not intersecting with moisture.
And
if they're inland,
just cold and windy.
Yeah, if they're inland trajectories, they're not gonna do anything other than drop the temps and then dry things out. The dew points will crash, and then we'll end up having winds. That's what we're observing.
So it's all about the position of that trough then.
That's right. So that trough coming in and the speed of the trough, and it has a lot to do too with the availability and how close that subtropical moisture is to the south.
So what would cause a trough to be positioned to our west off the west coast and be in a more favorable area to entrain that subtropical moisture, as opposed to one that dives down inland?
It's going to be the upstream wave train, and I think a lot of other dynamics that I don't completely understand. And one of the important things, and this kind of, I think, has been the case for the fall and maybe the case for the winter, is that we haven't really had any strong blocking patterns. We've had a pretty progressive jet stream, and we've had these sort of inland troughs that have dropped down and just cooled things off and dried things out and given us these sort of strong east winds like we've seen, like the Santa Ana winds. We're seeing something similar to that today. It was really windy overnight with that cold air in the northern Rockies and Great Plains sort of sneaking back east. And then you can have the ones like where there's a storm system forecast for next week on Christmas Eve that is going to have the trough form off the west coast and progress inward. And so I think it really has everything to do with the upstream forcings.
It's all upstream.
For sure, man. Yeah.
Wherever you are, it's all upstream.
Is that your bumper sticker?
And you're just chasing your
Wherever
tail.
you are, there you are. That's right.
Wow, that's
you
brilliant.
Like that? I know. It's pretty good.
Don't get ahead of yourself.
I know. Believe me, I'm not.
Yeah. So you had mentioned that we're sort of still in that pattern and on the horizon for over the holiday week.
Yeah. So it slowed down a little bit. There is some indication that the Mann-Julian oscillation was at play in November, and so that's going to give you some indication of, and you can sort of see it coming, is this large upstream forcing of tropical convection that can then translate and impact the jet stream, and then subsequently you'll see a jet stream pattern adjustment that we can see coming. And I think that we saw a little bit of that in early November, that it was going to get busy. Right now, things have really quieted down, and there's very little signal out there. The Pacific is not, kind of yielding anything in an ENSO sort of way, and the MJO it's really unknown if it's going to fire up again.
So there are no, aside from maybe a little bit of that boost from the MJO, there are not other widespread or large climate drivers that are influencing these patterns?
No, not right now.
But what about, so you mentioned ENSO. Now, it is in a neutral phase, and we can talk a little bit more about what people think is going to happen for the rest of the winter. But in terms of a neutral phase, we tend to think of maybe the jet stream having a little bit more leeway. It's not forced more often than not north or south.
Yeah.
And so there is that opportunity for those progressive troughs to move through maybe more frequently.
There's no big rocks in the stream upstream that you'd expect to see the jet stream sort of working around or being forced and then having these sort of standing wave patterns, right? Which is really what we see when we talk about strong El Niños or La Niñas, that there's some big, massive forcing in the atmosphere that's somewhat immobile. So it just keeps giving off energy and the atmosphere keeps responding to it. And then the atmosphere adjusts around it, and then it sends waves downstreams that are fairly consistent. We don't really have that right now. So weather becomes at play. And so then I think that really makes the longer term outlooks for the wintertime a real challenge. And you even see the Climate Prediction Center in their discussions really struggling. And there's a bit of a lean towards drier than average for southern Arizona and southern New Mexico, but it's not a real strong anomaly. And it seems we were kind of talking about this offline.
Let's turn to this later though, because I do want to sort of look.
You want to talk about it now?
At the models.
What else do you want to talk about?
Well, snowpack, I guess, is the only other thing, because 'tis the season.
I've already moved on to the rest of the winter. So.
Yeah, well, maybe we. What about Arctic oscillation? Anything that
you keep wanting to drag out the Arctic oscillation?
Yeah, I do want to keep, because the Arctic oscillation has somewhat of a signal. Maybe not here in the Southwest, but when we think about the broader U.S. temperature. When you have a positive Arctic oscillation, you tend to bottle up the cold air. The jet stream around the Arctic region is faster and keeps that cold air bottled up. And conversely, when you have that Arctic oscillation index in a negative phase, it basically means that cold air isn't as bottled up. So you can have outbreaks of cool condition, predominantly in the eastern half of the U.S., but there is some indication that might actually bleed over here into the Southwest as well.
It doesn't have a lot of impact on us here, but I mean, it can have some sort of secondary impacts. We can see some cold air seep in from the east in some of these backdoor cold
But you're
fronts.
not, you think...
I'm not a big fan.
Yeah.
No, not really a big fan.
You just don't think it's...
I don't think it exists. No.
It's just made up.
I was just going to see how far you went down. No, actually, no. It's a real thing. It doesn't tell us much. I think for the weather down here
in the Southwest.
Here in the Southwest, it's very important. It's like the North Atlantic oscillation, the Arctic oscillation are very much tied together, and it is a really important forecasting tool for the continental divide.
But if everything is upstream,
meridian.
Eventually,
it goes all the way around.
That upstream would.
That is if you ascribe to the Earth being round and not being a flat planar. And so typically what happens is it just falls off the other edge.
Oh, I see.
Right? And so those wave patterns never make it back around. So
okay. I got you on that one, I think.
Yeah. I don't know who got who on whatever there.
Okay, so you think, though, just to put a bow on that we should just move on from the Arctic oscillation.
No, I think it's interesting. I think that the AO, there have been a couple of cold air outbreaks, but there hasn't been a persistent stuckness to the atmosphere. It hasn't gotten stuck there. And so I don't think that the AO has really explained a lot of what's been going on. And the Arctic oscillation is looked at as this whole the idea of sudden stratospheric warmings and sort of breakdown of the upper level stratospheric polar index can then be a precursor for the AO to have certain phase changes. So people in the eastern U.S. really look to that to see if that's happening. Then subsequently, weeks later, you might start to see these cold air outbreaks. Really hasn't been the blogs that you and I have talked about, follow, haven't really seen that. Haven't really seen that manifest yet. And the forecasts, I'm looking at one of the Arctic oscillation forecasts for the rest of the month. This suggests it's going to go super negative, which would mean that cold air gets kicked open and starts to spill south. But then it trends back to neutral, which is really just the models struggling to figure out what's going on.
Right, and the Arctic oscillation sort of evolves on weekly timescales. So.
It does. And it's like without ENSO and without MJO now, we don't have anything to go on.
PDO?
Sure, man. You're baiting me.
The QBO?
The
I am
QBO.
baiting
No,
you
the
on that
QBO.
one.
Oh, QBO. I wish I understood what the QBO was. I read about it. I just don't quite get it.
Yeah.
And it's another forecasting tool, the quasi-biennial oscillation. And
well, let's get to forecast in a minute, but I did want to bring up the end of the year temperature record, because at the end of the year, there's always mini talk about where global temperatures came in their ranks. And given that there's only a couple weeks left in 2019, it does look like the global average temperature will come in at the second warmest on record, behind 2016, which is notable because this year was not an El Nino year.
Right. Didn't have the gas. Yeah.
And 2016 was. And that matters because in an El Nino year, you have more...
Yeah, you're juicing the atmosphere with a little extra heat.
Right, because you have warmer sea surface temperature waters across much of the Pacific. That adds a little bit of an extra... By the way, do you know what the added amount of heat globally would be from an El Nino? More? Are we talking like a couple tenths of a degree or...
4 petawatts? I don't know.
But how many zeros is in a
I don't know.
petawatt?
I just like saying that. I think it's a cool word.
But
I really don't. I don't know.
So when we look at the global temperature pattern for the last 3 months, actually for October and November, what's really interesting is for October, the entire globe outside of places in Antarctica is warmer than average, with a few points here and there which are below average. But the real bullseye for anomalously cold conditions in October is in the Western U.S.
Yeah, I know.
It's really
very telling.
Yeah, it is.
I don't know what it tells, but
any thoughts on?
No, I think it felt mild. I mean, October was very cold, and it's interesting to look at these maps as you sent around. Is that it was only below average in the entire planet in the Western U.S.
Yeah.
So global warming was not canceled based on what we experienced here.
Well, that's right, and it was the second warmest October
for the planet.
Since 1880.
Even though we end up there was some minimum temperature records broken in the interior West in October at the same time that the planet had its second warmest October on record. So just crazy to see how that all shakes out.
And fast forward 1 month to November, and November was also the second warmest November on record. And then that cold bullseye shifts from the west to the east. And basically the east is one of just a few places globally that has below average temperatures.
Right. And so you can see it's just that subtle progression in the dominant jet stream pattern was moving that little cold blob there. The jet stream was progressive, moving around, but just the recurrence of where it was moving that cold air from north to south shifted slightly from October to November in the Western U.S. And the rest of the planet, I mean, you don't see anywhere in any of the other continents having that level of cold anomalies that we had here in the West. So it was, kind of an unusual situation.
So 2019 is going to be the second warmest year on record. We'll see what 2020 brings.
And just, and this will kind of lean into our forecast here discussion, is that the Pacific Ocean is warm everywhere. It's from the Gulf of Alaska right down to the equator is above average. It's just everywhere. And it's not an El Nino situation. The anomalies in the spots that we normally look are not enough to make it trip over into that category. But the entire Pacific Ocean is warm. It's really quite interesting to see.
Much of the Atlantic is warm too.
Yeah.
Okay, so just very briefly, let's just go over the snowpack situation early in the season. And this, as one would expect, it largely mirrors the rainfall pattern. So basically above average, for the most part, above average snowpacks in the upper elevations in Colorado, Utah, some in Arizona and New Mexico. It's a mixed bag though, and which is not uncharacteristic this early in the season because you can get snows, but then you can get warm conditions that melt them away quite quickly. But the inflection point basically is northern Nevada, California, and Utah, and it switches from above average to below average in the northern Rockies and the Pacific Northwest. And that is largely the result of more or less the trajectory of the jet stream. So we've been the beneficiaries here in the in the southern tier of the West, and the Pacific Northwest has yet to. Well, they've gotten rain, but they just haven't gotten as much as they usually do.
Right.
Anything you want to say about snowpack there?
I mean, it's good we haven't had a wet November in a long time. I think having a wet November, there's some research that suggests that helps set up subsequent accumulation of water in the soil. So it can kind of prime the system a little bit. So that's not, and we just haven't had a wet November in many years. I think
Is it a harbinger?
No.
There's no predictive power with November?
Nope. No.
November and regressions don't have any significance?
No, I don't think so. We could do the eyeball regression right now. No, I don't think that there's any suggestion. We had a very dry November last year and ended up having a very wet winter. I don't think it's gonna be the inverse. I do think we're really on this at best 2-week outlook schedule for the rest of the winter. Quite honestly, it's just sort of the wait and see and looking at the 2 weeks to see how things evolve.
What creates your optimism or pessimism then?
I'm a hopeless optimist because there's this chance that it could be awesome. And it's not until it's almost done and it's been miserable that I'll really get grumpy.
Well, so this is a little bit different than your sort of monsoon mood, because you're kind of like...
Yeah, you're right. I'm very inconsistent.
Yeah, your emotions are all over the place.
I was thinking about last winter and how fun that was. And I was like, yeah, we can do it. We have that potential to do winters like that down here. But there's no way that's going to happen again.
Even, go back like, 3-4 years ago, or even two years ago. Yeah.
2 winters ago was horrible.
You were still, if I would have asked you how you feel on any given day, you'd be like, yeah, it's going to rain tomorrow.
Because that's the way I function.
Outside of the forecast.
See, the monsoon's a little bit different. You have this short window. You got to be there. You got to show up. You got to be there. If you're not,
the time is ticking away.
July 20th, and you're not in the game. Yeah. I'm done. Like, I walk away from that season. That
season
doesn't
the same apply here?
No, not at all.
Like a three month window.
It's like November, and we've already had this amazing performance, and I'm like, shoot, we can do it again.
Time we have such a short window?
Nah, we can do January. We got February. We got March even. We've done March. April. Why not?
No, April is
last
May.
Last May it rained.
Oh yeah, if you.
This is half a year, guys.
I am definitely sensing some inconsistency. I think we've got 3 solid months in the winter to get.
You check in with me at the end of January. We'll probably have already had a 95-degree day. Won't have rained.
What's the amount? What's the climatology for March? How much rain do we get?
We don't get much.
We don't get much.
I bet it's like 3/4 of an inch.
Yeah, I would have said it was a little bit more than that, like an inch and a quarter, inch and a half.
I bet it's not even that much.
Well, I'm just saying, like, December, January, and February and March. So in my view, there's a 4-month window, which is not that much longer than the monsoon. And so I feel like the time is ticking.
I think anything's possible. See, the monsoon is, it has such a hard edge at the beginning, and then it's game time until basically the first week of September. I mean, that's like the core of play right there. Mm-hmm. The winter time, we've already had play in November. I mean, it's like, the warm-up's been good, and then we're going to probably get rain next week with Christmas.
So you think there's more consistency in the winter then?
No, God, no. There's way less consistency
than the monsoon in comparison to the monsoon.
Absolutely, yeah. The interannual variability with wintertime precipitation has enormous. There's so many dry winters and then a handful of
we should look at
epic wet.
This data, because I haven't looked at that.
Yeah, if you look at the monsoon in general, and again, it's on every location, it's got much narrower variability. And so in the season, it usually rains about this much. Not everywhere out at the same time. But
I wonder if the ranges are similar, because at least in this part of Arizona, the monsoon and the winter precipitation are similar.
It depends on what you lump in and what you lump out. Like if you put October in the winter or you put it in the summer.
Forget about October. Yeah. That's like its own tropical storm season. It is,
yeah.
So to me, it's November, December, January, February, March. So it's a 5-month.
I have irrational exuberance right now, which I have a lot in a lot of stuffs. If you were smart, you'd get me on some kind of, we'd game this out some way and bet some money and I would eat it.
So what's your take then on the winter? Okay,
it's probably gonna be below average.
Wow. Okay, I'm totally confused.
You should be.
All right.
Welcome to my head.
That was amazing. Let's think about what's on the horizon for the projection. So you've already talked about ENSO kind of being off the table. I mean, we're sort of borderline, we're neutral, borderline. We're not borderline El Nino, are we?
Not really.
Yeah.
No, it's pretty neutral. I mean, there's warm water in the Pacific, in the equatorial region. The sea surface temperatures in El Nino 3.4, the magic box we look at, have been bumping around above average. I doubt that right now it's going to trip anything into official categories. And the
forecasts are like 70% neutral with marginal percentages of El Nino. I say marginal because I'm not looking at that figure right now, but I do know that neutral is 70%, which is really high. I mean,
yeah, I mean, they put most of the eggs into the neutral basket as far as the wagering right now.
Okay, so then recognizing that when we talk about seasonal projections and seasonal forecasts of precipitation,
seasonal outlooks,
yeah. Thank you.
Yeah,
there is a technical definition between.
I think so. I think projections are different.
They're a little bit more definitive.
I think I would say less definitive.
Projections than
I don't
outlooks?
know. I
always
really
thought
know.
outlooks were more qualitative.
Climate projections is not being forecasts, and is forecasts not being outlooks.
So what's the difference between a forecast and an outlook?
I always think of outlooks of maybe being probabilistic and less confidence, and forecasts having more confidence.
Yeah, I was thinking that outlooks were more maybe qualitative isn't the right word.
I would say in rank order.
But they're all probabilistic no matter what, like a forecast.
Forecasts can be deterministic, though. They can tell you it's going to be 45 degrees.
And that's when you run away.
Do
not believe a deterministic
a weather
forecast.
Well, not a climate one, right? Yeah, weather forecast. Yeah, not bad. I mean,
for the next hour.
Well, right. It's a forecast. What do you want?
Okay, so admittedly that these seasonal climate forecasts, the main predictor is ENSO. And when you don't have a strong ENSO signal.
For the Southwest, for precipitation in the winter season is ENSO.
Right, but wouldn't it be geographic in that?
No, I think some other regions and seasons have other predictors.
Okay,
but you're right. The Western U.S., and also it's somewhat seasonal as well.
The forecast, as you mentioned before, the official forecast sort of calls for slightly elevated chances for January, February, March rainfall in the Pacific Northwest to be above average, and slightly elevated chances for parts of California and Texas to be below average. And then everything else is sort of, well, actually, no, I should also say the northern tier of the U.S. and Midwest area is also forecasted for above average. Did I get that right?
Were we talking precipitation?
Yeah, we're talking precipitation.
Yes.
So that's the official forecast.
Yeah. Yep. For the upcoming season. Right. Yep.
And then when you look sort of under the hood at the models that are going into, that's a sort of summary. That's looking at all the model guidance and a bunch of other tools, and the forecasters are narrating that picture. When you look at the 7 or 8 other models that are used to contribute to that picture, there's kind of an interesting feature. One of them is there's a very robust dry signal off the Pacific Northwest coast. And that shows up in basically 6 of the 7 models. And I don't know if you have any thoughts on what the heck would be driving that, because that to me is a signal that's fairly consistent. And so that would lend itself to a little bit more credibility or believability, if you will. I mean, all of these different models are picking up on the same thing. To me, that's suggesting that there's a predominant ridge that's showing up in that location. So what's your take on that?
Well, I think the Climate Prediction Center discussion hinted at this a little bit, is that the arrangement of the sea surface temperature anomalies across the Pacific Ocean are going to produce anomalous thunderstorm activity in a certain part of the Pacific Ocean. And this would be sort of the date line, and then slightly west of the date line, with suppressed convection on the east side of the date line. If that were to manifest itself and persist, then you'd get this wave pattern that would lead to that pattern of anomalies downstream. And so I think, and I think that's it. But it's not particularly strong, and we wouldn't expect to see that. It's not a strong El Nino, and it's not a strong La Nina pattern, and so it shouldn't necessarily be a sort of a persistent anomalous convection across the Pacific Ocean. So I expect that weather scale, time scale variability.
You're still going to get a lot of
and MJO. I mean, and then there's the subseasonal variability, which would be like MJO initiation and propagation. So this ends up being an interesting model signal, but I believe a very low confidence outcome.
Yeah, and one thing that I think about when I look at these patterns is, let's say that pattern, a ridge pattern, is robust. Its location, if it shifts a couple 100 miles to the west out to sea, or maybe a little bit more than a couple 100 miles, or if it shifts inland, that is going to have marked difference. It can flip the sign of precipitation.
Absolutely. So or there's not a persistent pattern, right? I mean that's suggesting that there's some pattern that accumulates that precipitation anomaly, but maybe isn't necessarily a standing wave or a blocking pattern or something like that, right? And so I think that's more what the models are hinting at, is that maybe there'll be a frequency shift of more of these kinds of storms versus those kinds of storms. And again, the seasonal models out that far don't do the weather scale frequency statistics very well.
It's just interesting when you look at this, though, because only one of the models of the 7 has sort of a wetter signal for Arizona and parts of New Mexico. And 3, 4 have slightly drier signals for Arizona and New Mexico.
This is so frustrating business we're in. They may be right. It's been interesting to watch. I like to look at the 6 to 10 day forecast, the 8 to 14. There's an experimental week 3, 4. And then there's the seasonal forecast, the 1 month, the 3 month. And so the confidence obviously increases as you get down to the 6 to 10. So the 6 to 10 and the 8 to 14 have been cool and wet for many weeks now, sort of progressing forward, while the week 3, 4 is always dry. And so the week 3, 4 ends up being wrong, and this sort of near-term forecast ends up being right. Can that keep going? I don't know. But it just to me, it suggests that the variability that we're going to deal with this winter is at much shorter timescales. And there's not much signal to look at further. This very well could be that this ends up being a very dry winter, but it's not a foregone conclusion because we don't really have anything to hang our hat on at this point.
And that's
my optimism.
That's your pessimism.
That's my irrational exuberance, is that, I don't know, could be good.
All right. So then
once we get to the end of January and we get into February and it's tanked, then I'll be back to normal.
Early February for those skiers out there.
Oh, we're already onto this. Yeah.
Where do they go?
Where there is seasonal snow, fall, and snowpack from a climatological perspective.
Wow. We really needed you for that one.
I just got through saying that the week that I can't see back 6 to 10 days, and you want a forecast for February.
I know.
I'm ready. I'm ready to do that forecast.
Wishful thinking.
You just got to get me into the right time.
Okay, so Mike, I think we know your viewpoint here. It's going to be a pretty spectacular winter season,
I'm hoping for that. I know that it won't come true. Let's just put it that way. I asked for the Red Ryder BB gun. I know I'm not going to get it. But it's going to come out at the last minute.
You won't shoot your eye out.
Wrapped, and I won't shoot my eye out, but I will shoot my eye out. Yes.
All right. Well, any last second parting shots before we say goodbye to 2019?
Yeah. Happy holidays, everybody, and congrats again, Zach. And enjoy the season.
All right. Thanks, everybody. Okay, I didn't realize it was at 3. I thought it was 4 to 6.
We gotta go then, man.
All right.